Oh,
And then I have kind of a sudden too that well, if I could hold it, church there. There's some that'll some won't care. I've had a couple in my group. I'm gonna show keep hand on the one the whole time. Well, because he's gonna run. I don't know. We'll talk about the same one. I have a few, but his mom said that she got a new phone.
it was nice. I enjoyed it. Oh, no, it was good. I mean, I was talking about Star Wars coming out in 1977. My wife and I went and saw that. I'm right there with you. Yeah, I think the Star Martian. Right?
All right, we're going to get started with Nerd Church tonight. We have some exciting experiments, which we hope we don't burn down the church or blow anything up, but we're going to try not to. So we are recording, and we are going to try to repeat questions because people are watching along. We have some people that have been here the last couple weeks that could not come tonight for family obligations and health concerns. So they're going to be watching. So we want to make sure we get all the questions. And we're excited about this series. We've enjoyed doing this series. It's been awesome. Even though Jeff is not up every Sunday with me, we meet once or twice a week, and we work on all this and share all this stuff that's already in his mind with you. It's amazing. So I appreciate you, Jeff, just participating with us. And we're talking about doing another one in the spring, which we're going to begin working on. So because it's been a great response from especially our teens for this series. Like, this has been really good conversations in our youth group. I've had great conversations with our teenagers, and so it's a good topic because they don't really agree with what they're being taught all the time, but they don't have any other information to go against what they're being taught. So they just kind of wonder. And so being able to help them understand God's word in a different way and talk about what's going on in the scientific world and the political world, and ultimately helping them figure out, has been huge. So we're really glad we can do that and have those conversations. But I also get to have these conversations at home with my 13-year-old, my 11-year-old, my 7-year-old. So it's been a blessing for us to have that and be able to talk to that from a stage because it's important to us as a church. So thank you for coming to Nerd Church to go deeper with us. We have some questions for you tonight, and then we got some really cool experiments that we're going to share with you. And then Jeff has some show and tell, which is awesome. So first question, what can we see in space? What do you think we can see? Like, we can see, like individuals can see. Anybody would know? The moon? The planets? Stars? Okay, good. Comet? Okay. We had 100 unicorn asteroids, meteors the other night. I made my newsreel because it had unicorn in it, so I noticed that. Do you know what that was? The unicorn shower that we just had?
Well, meteor showers happen several times a year, and basically what people don't understand is we have these short period comets that whip by the Earth every 2 or 3 years, or they orbit the sun. They're in very, short orbital periods. And some of these comets pass through the Earth's path around the sun, and those are the meteor showers that we have. The Earth goes into these particles left from a comet as it got close to the sun. A comet has what they call an ion tail and a dust tail, and the dust tail is the particles that they leave, and then our Earth goes through it, and that's why you see these little meteor showers at certain times of the year, where these little parts, there's probably no bigger than one of your fingernails or something at the largest, swinging at the Earth's atmosphere, about 45 miles per second.
Yes.
I kind of talked to you about this before at the Pines, and you talked about comets going around the sun and leaving debris behind. Is there a way to measure if there was a Big Bang with debris being left behind over and over and over again? Can you measure in any way time by how much a comet loses?
It's
Let
hard
me
to
restate the question just so they can hear. So is there any way to measure time by examining like the debris left over by a comet trail?
And there's really not, because comets can take various forms, just like minor planets, what we refer to as asteroids, can take various forms. You always see these movies about, we're worried about an asteroid hitting the Earth. And this is some of the research that I do from my observatory as I monitor these minor planets, especially the near-Earth orbiting minor planets. But a minor planet, what we do is we do photometry data, which is a device I put on the back of the telescope, and I look at the light coming off of this object, and you can figure out the rotational period of these things. And they're bimodal, most of them, so, which means they have multiple rotational axes. They're not just one, like our Earth rotates around its axis. There's multiple axes that these minor planets tumble on. And you do the light curve, and depending on, if they're very fast rotating, then they're very massive. They're made out of, heavier elements like iron and, rock, things like that. There's some that orbit a lot slower, rotate a lot slower, and those are loosely constrained. So if you were to, you see the movies where, I think in Armageddon, they launched this, nuclear explosion to break up this asteroid. But that's going to cause more damage. Now you got a bunch of little pieces flying at the Earth instead of one piece, one large piece. But what they're trying to do is they're kind of come up with a way to, if we have these threats, to eliminate them. And there's several ideas on the books right now where they're going to launch a probe that maybe reflects light from the sun and hits the surface of the minor planet, and it starts outgassing. And that outgassing is like a thruster. And if you get the minor planet out far enough away from the Earth, all you got to do is move it enough in its orbit so that it misses the Earth. Or they're going to actually land a rocket on there and then fire a rocket engine to move it off course. But there's a lot of different ways they're going to do this. But no, you really can't tell, because depends on the mass and the density. Is how much matter it's going to lose as it orbits the sun.
Good question, yeah. So we have some pictures of things that we can see in space. The first one here is the International Space Station. This is a picture taken by Jeff with his observatory. Isn't that cool? So you can actually see that in space with the right telescope. And that is what it looks like when we see on pictures, and you can see that through Jeff's observatory. How long? That took, 15 frames?
Yeah, 15 frames. This is probably some of the hardest photography to do, because this thing's moving, in a circumpolar orbit around the Earth, or close to a circumpolar orbit, at 17,000 miles an hour. So what I've got to do is every object that is in orbit around something has what they call TLEs, two-line orbital elements, and you use those numbers, and I have to plug them into my telescope to program them out to track this thing as it goes across the sky. So the telescope has to be moving and following this thing across the sky. And then I took a regular Canon camera, a digital SLR camera, and I used an orange filter on this and an infrared filter, which only passes those two frequencies of light. And then I took 1/2500th of a second exposure at 600 ASA, that's the gain of the camera. And I took 15 frames, and then I stacked them all together to make.
Yeah, we all would have done the exact same thing, Jeff. So, and the cool thing is, we were up at the hills, Haven, when we had our trip, and Jeff showed me in the sky. This thing was moving across the sky. It was like you could just point and follow. It was that fast across the sky. And then it got 3/4 of the way and it disappeared. And I didn't know this before, but it disappeared because it entered the Earth's shadow. And so, that's why it didn't complete a circuit across the sky. So when it disappeared about a quarter way, it just disappeared. And everything that tracked across the sky disappeared. And it was Earth's shadow is why you couldn't see it, which was, I never knew that was such a thing. I know the Earth had a shadow. I just didn't know stuff would disappear into it. And so that was cool. So we wanted to show you that Jeff took that picture. It's pretty neat. And the next one we showed this morning, so we'll just go quick. The one that you can see is Apollo 11. obviously, is when they landed, and those little lines are where they were walking around. That's actually their foot trails, and they can see that with telescopes and all that fun stuff there. So, yeah.
Is there like no wind or anything like that that would blow dust?
Is there no wind,
No,
Jeff?
there's no atmosphere, so there's no erosion.
So nothing would cover the trails?
No, and that one thing I'd like to point out, because this is a question that I get asked, but if you look in the Apollo 11, you see a little arrow that says LRRR. That's a device that they put on in every mission, and basically what it is, it's a laser range finding device, and what they do, they use observatories all over the world, and they fire a laser at this reflector, and it's a rectal reflector, and it actually reflects back the laser pulse that they send out, and they do a timing on that, and they can tell exactly how far the moon is away from the Earth to sub-inch accuracy. And what they're finding out is the Earth and the moon are separating by about an inch every year.
Yeah. And if you look above where it says like LM, up around there is where the flag is. There's another picture that's not on there, but you can see it down Apollo 17. There's a flag. So the flags they take up there are still there and still visible up there on the moon. So that's pretty neat. Next thing, we have a little show and tell for you. Meteorites. So meteorites are, no, this is a question we had. We did not, we had to set this all up and it disappeared. What is the difference between a meteor and a meteorite? Anybody know? Ooh, I see hands going up and down. Go for it.
Meteorite is in flight, and meteorite comes through the atmosphere, and a meteor is still going. No, I'm wrong.
You're close.
Am I backwards?
No, you're close. When you have a piece of rock in space, it's called a meteoroid. When a meteor enters the Earth's atmosphere, it's called a meteor. If it strikes the Earth's surface, it's called a meteorite.
Yeah.
So you're
Yes.
meteor wrong.
Well, that's what. Well, that term is used. That term is used quite a bit by people that go out and look for, and we'll talk about that in a little bit. That look for meteors, because there's a lot of iron in the Earth, obviously, and when we find a meteor that's we use our metal detector, we find something that might be a meteor, we look at it and say, oh, that's a meteor wrong, as opposed to a meteorite.
So that is a thing.
Yes.
You were right, yeah. Not to be confused with Metroid, which is a great video game. So that's a different thing. Spelled very similar. So, Jeff, you have some things you want to show us about meteorites? If you want to show.
I've got to show a couple here. There's basically three classifications of meteorites. There's iron meteorites, which these are. Then there's stony iron, and then there's stony meteorites. The stony meteorites are called chondrites, and we'll talk about that a little bit, but these are two iron ones. This one fell in Russia in 1947. You can go ahead and pass it around. That's an iron meteorite. This is that's just a fragment of it. There's a lot of these samples all over the place. Now, this is the Gibeon meteorite that fell in Africa. And what's really neat about this, when you look at this is how we can tell that this came from space as opposed to something that we found on the Earth, because it's got the Wittgenstein pattern on it. And you do that by etching the meteorite with sulfuric acid and methanol. And it puts this little pattern. This pattern can only be formed in zero gravity. So we'll pass it around. And then you look on the bottom, you can see some of the fusion crust where this thing came through the Earth's atmosphere when it entered before it hit the Earth. But you can see that little pattern there. And then the chondrites are, like I said, they're stony. And you're going to see, we have the Earth. If you look at the Earth, we have a core, which is made of molten metal. Then we have the mantle. Then we have the crust. Well, a stony meteorite, you can tell because none of that stuff is congealed like it. You don't have a big clump of iron in one spot. You see these particles of iron all through the stony meteorite. So there's chondrites and there's achondrites. Chondrites have this iron in it. Chondrites do not.
And do you want to show us how you find these meteorites? Well, I know you didn't find these.
No, not these, but this is, I have some friends, I go out all the time. There was a meteorite that just fell in Hamburg, Michigan last year. And we've been doing a lot of, looking around for that guy. But This is a metal detector, and you can't just use any metal detector because chondrites are made of stone. They have a little bit of iron, so this particular metal detector is a multi-frequency. It'll go from about 8 hertz up to about 40 kilohertz. So this is what we use to detect, meteorites. And then once you find one, then you get your shovel out and dig it up, and then this is a more pinpoint accurate one. And we'll try and pick it up with a magnet and see. Most of the stuff, for every maybe 100 digs that we do, we find junk like spoons and, just garbage every once in a while. Those are meteor-wrongs like we talked about, and every once in a while you hit a meteorite.
Doesn't a meteorite go through breakup when it enters the atmosphere and stuff like that?
Yes, and you have a lot of different, smaller falls that they find, and they call that a strewn field. They'll go ahead and there's actually software you can look at it, you can figure out the trajectory this came into the Earth's atmosphere, then you can calculate a strewn field so you know where to go looking for these things at.
Eric, yeah.
Jeff, one of the ones that you passed around, it said pound 18 something, and it said the weight was in kilograms, like 28,000.
Yeah, it was.
That was a giant, they chopped up in the trunk?
Well, no, basically, the Earth does a real good job of protecting us. So does the planet Jupiter. People don't realize this, but Jupiter is like the vacuum of the solar system. Anything that, gets close to Jupiter gets sucked into its atmosphere, so it saves us from getting hit by a lot of different objects. And all you got to do to look at the moon at night and see how many craters are on the moon. Again, there's no atmosphere, so anything that goes into the moon is going to, hit the Earth's surface and become a meteorite. The Earth's atmosphere protects us, so basically, when you have a meteorite streaming in so fast, you get these pressure waves that build up in front of the meteorite, and what ends up happening is these cause the meteorite to explode. And a lot of times, the smaller particles burn up before they hit the Earth. Every once in a while, you have some that do hit the Earth. But they just had one in Russia here a couple years ago that busted a couple windows and sent some people to the hospital from the sonic boom. But, we're fairly lucky. We haven't been hit with anything as large as the one that took out the dinosaurs, the Yucatan.
Was it a meteorite, the one in Arizona?
Yes.
Yeah,
No, it's funny. Rob and I, we rode our motorcycles in Arizona about 5 or 6 years ago. Yeah, we actually visited, and we were sitting there. They had a Subway restaurant there, and I got to tell the story because this is Rob. This is classic Rob. We're going into the Subway to eat, and Rob goes, "Jeff, this is amazing. This meteorite fell right next to a Subway restaurant."
So we've got another question for you. So we talked about meteorites, and we want to talk about stuff kind of moving through space. But how do you measure the speed of light on Earth? Does anyone know? How do you measure the speed of light on Earth? Carefully. Well, great. Go ahead.
Well, I mean, it's a measure of speed or light over a year. I'm guessing that reflecting or reflecting measure. Wait, no. I'm just thinking if
I think that's a good effort there for sure. Yeah.
That's how they actually measured it years ago. So you are correct, but there's better ways to do it now, and you get more accurate. I mean, we're going to do a little experiment here with a microwave, and this is something that you guys
You use this
can do with
trusty
your
microwave
kids
to
at
measure
home. It's basically an experiment in quantum mechanics. So if we can get to the next slide, I can explain how this is going to work. But everybody ever seen this before? This is the electromagnetic spectrum. So you can see to the far left we have the gamma rays. These are all nasty stuff, gamma rays, X-rays. And then you see the ultraviolet spectrum. This is where the sun, gives you sunburns and things like that, the UVB and the UVA. Then that small little area there, the visible spectrum, is what our eyes are sensitive to. And our eyes are very sensitive, or most sensitive to green light. So the little cameras that you buy, the little CMOS cameras you buy at the store that take digital pictures, they use what's called a Bayer mask. And the Bayer mask has 2 green filters and a red and a blue to approximate what your eye sees as far as what true color is. But that's the only area that you can see, we can see as a human being with our eyes as a visible spectrum. So a lot of telescopes use, infrared, which is farther to the right. Then you have the microwave, which we're going to do in this experiment in a microwave, and then you have the radio waves there. So the frequency increases as you go from right to left, so the energy increases. The wavelength is shorter, and the energy is higher as we go from, like I said, right to left. So what we're going to do is, if you can bring the next one up, the speed of light is measured using two things. We need to know the frequency, and we need to know the wavelength in order to calculate the speed of light. So you can see the top line shows a higher frequency. So you notice that the waves are closer together. This is what's called a sine wave. And then the lower frequencies have a longer wavelength. So you can see the short wavelength. So if we look from here to here, that's one wavelength of light. And that's longer than this one here, which is short. So here's a question that I'm going to ask. Does anybody know and Rob, you probably know what this is, so don't say anything. But okay. When you turn on your radio, does anyone know what the difference is between AM and FM? Yes, you're right, but there's another thing you got to look at. Does anyone know what FM stands for? Frequency modulation. So AM stands for amplitude modulated. So basically, when you're listening to an AM radio, this sine wave is changing in amplitude this way, up and down. FM is changing in frequency this way. So that's a difference between AM and FM. And again, FM is a lot higher frequency than AM is, so you can't get over, you can only pick up FM in line of sight. So once you go over the curvature of the earth, you lose the signal because FM can't follow the curvature of the earth like AM can. So for those of you that are flat earthers, there's one of the reasons why the earth isn't flat, right there. So we're gonna do an experiment with a chocolate bar, and what we're gonna do is we're gonna put this in the microwave, and you got to take the turntable out because again, when radio or any kind of electromagnetic spectrum travels through space or whatever, it propagates through space. But in a microwave, because microwaves are dangerous, they have to shield the inside of the microwave to keep those microwaves from getting out of the microwave oven. So in that instance, and if you guys want to do the standing wave ratio, we're going to end up, there's standing waves that are inside the microwave, which means that they don't move either in frequency or amplitude. So you get these standing waves. And in those standing waves, you have this point here would be what's called a node. There's another node, another node, another node. These are antinodes right here. So what's going to happen is we're going to put the chocolate bar, let's turn it upside down. Yeah, so that we can. Then we'll turn it on for about 15 seconds. So what's going to happen is, that's why they put these turntables in microwaves. If you didn't, it would cook unevenly because of these nodes and antinodes. And this is, in physics, is called constructive and deconstructive interference. So when you have radio frequencies that are in phase with one another, they increase in amplitude. As soon as they get 180 degrees out of phase, both signals cancel themselves out. So these are all, let's go ahead and 15 seconds. And
That goes for audio too, right?
yes.
Yeah, I remember.
Our sound waves and light waves have the same properties. So yeah, that's all. So let's see if this is. Yeah, we have to go longer. What we're going to look for is we're going to look for these antinodes, and we're going to measure the distance between two of the antinodes. Then we're going to convert that to meters, and then this microwave operates at a frequency of 2,450 megahertz, which is 2,450 450 million meters. Okay, we can start seeing one here. Oh, it's,
Has anybody ever, put a, meteor under a microscope? Maybe,
yeah, they do it all the time.
oh, okay, I was just checking to see if honey, I shrunk the aliens, maybe.
Okay, so I'm looking at these two marks here. There's about 6.1 millimeters. Okay, so 6.1 millimeters. If you want to take a look at this, you can see what's happening here. We're looking at these soft spots here in the chocolate bar.
Those were soft spots that just,
It's where the antinodes. No, I had to stick my finger in there to see where they were, because there's parts that are hard and there's parts that are soft, and that's why the microwave has a turntable, so it cooks here and here.
oh, I see. Right.
We'll show you the next image.
So when you put your finger in there, you touch one side and then you went to find where it ends again and you're measuring from end to end.
Right,
Okay.
exactly.
Yeah,
This is hot, so
We're gonna do the science experiment at home.
right. You can see one there and one there. Now you guys can have some chocolate once this cools down. If you guys want.
I know. Do you mind if I feel?
Yeah, go ahead.
So
It's probably starting to
right
melt
here,
now.
Right there, and then right over.
Yeah, we're looking
here.
at the edges though, because that's a big pool, so we got to find the edge of it where it gets hard.
On the inside? Oh,
Yep.
okay.
So it's, sure. So if somebody's got a calculator, again, this distance that I just measured, 6.1 millimeters, is half the wavelength. So we have to multiply that by 2 to get the wavelength. So what we're looking at, you see where the crest is? That's an antinode, and where the trough is an antinode. So that's where the microwave food was heated at. And then the areas halfway between the two are nodes, where there's no heating at all. So because we're looking at, one of these was the trough and one was the peak, that's half the wavelength. So we have to multiply 6.1 by 2. So if we do that, we get 12.2 millimeters. So we know that the microwave works at 2,450 megahertz. So we have to convert that to meters, our measurement here. So we take, let's see, 12.1 to millimeters to centimeters would be 0.12. And then to, well, wait a minute, let me start again. 6.1 I said, so 12.2. So it would be 12, it would be, well, we got to go to meters. So decameters is going to be 1.2 decameters. So meters is going to be 0.122. So we're basically taking 12.2 and converting it to meters, which is going to be 1.22. So if somebody has a calculator, they take 1.22, and that's the wavelength, and we multiply that by the frequency, which is 2,450. What number do you come up with? 2,989 point something. But we have to, because this is in megahertz, we have to add 6 zeros to that. So we're at 298,900,000 and some thousand something meters per second is what we end up with. Everyone follow what I'm going so far? So I've got the thing here. The actual speed of light in a vacuum is 299,792,458,000 meters per second. Yeah, 299,792,458 meters per second. So we came up with what? What was the first number? Somebody said 2,098.9, I think is what it's going to be in mass. So we're at 2,908,900,000 meters per second. So we're just slightly under the actual speed of light. And the reason for that is there's going to be an error because we're using a very crude measuring device here. We're measuring this in millimeters. And all of these wavelengths that we're measuring are in nanometers. They're billionths of an inch. So if we had something that could measure this a lot accurately, we'd get a lot closer. But this is some of the experiments you can do with your kids at home just using a simple microwave to calculate the speed of light.
And it's a delicious experiment. So. And it works on any microwave, but you have to read the back, and you got to get the
frequency that it
frequency of the
operates at.
microwave. So, and then it always the wavelength when you double whatever the measurement is, and you add that, it'll always get you really close to speed of light. So it doesn't matter what microwave. I just learned this week, and I was like, oh, let's teach everybody that. That's awesome. So, and then so with that, so we can do that and measure the light. So we have a question. Nope. And so we want to also talk about some of the properties of light because that depends on how they determine things in space. So Jeff, could you share with us a little bit about the properties of light because we need to know that to understand some more things.
Sure. Astronomers have to know a lot about the properties of light because that's one of the main things that we use to measure different items in space, different objects in space. So basically the first one is I've talked about photometry, and that's a device that actually measures the starlight that's coming from a star, the magnitude or the intensity of the starlight coming from a star. It actually measures the photons of light that are hitting the photon detector.
But this next slide will show you. Yeah, there we go.
This is another device we use. It's called a spectrometer. And with a spectrometer, this takes the white light that we get from a star, and it breaks it up into the visual spectrum. And from there, you can see a continuous light source over on the left, and then there's a gas cloud. So if a continuous spectrum passes through gas, we get a continuous spectrum with dark lines, and those dark lines are where the light gets absorbed. That's where you get the constructive or deconstructive interference at in the spectrum. And I'll explain that in more detail. The bottom one on the left shows just a continuous spectrum. If light is reflected off of a gas as opposed to passing through, if it's being transmitted from the gas, you get what's called a bright line spectrum, which you see in the lower right-hand corner. So astronomers use this to determine what that particular object is made of. And the next slide will show that in a little bit greater detail. This is all bright line spectrum. When we look at a star, now this is just individual, elements on the periodic table. You would see all these lines together if you were looking at a star, and the star contained all of these particular elements. So you can see the bright line spectrum that hydrogen gas produces, the bright line spectrum that helium gas produces, lithium, and then oxygen. So again, when astronomers say that, we know that this planet has a, methane atmosphere or whatever, this is how we know because we can look at the fingerprint of the spectrum and know exactly what that particular star or that planet is made out of.
So there's a lot. Light is how we observe space, the light that comes to our planet, and how we make calculations and discoveries, and so it's neat. So Jeff, how do they discover planets? Because we know the planets in our solar system because we can see them. Like tonight, if you could go outside and see the stars, which we just checked beforehand, you cannot. Venus and Jupiter are together tonight. You can see them right next to each other in the night sky. Not here because we got clouds. But how do they discover planets? Do we have a video here first?
Yeah, well, the same spectrum I showed you, those bright line and dark line spectra appear at the same spot on the spectrum all the time, unless we put a velocity along with that particular element. So I'm sure that everybody has heard about police radar, okay, but does anyone understand how it works? It uses the same principle that astronomers use to figure out how fast things are moving toward or away from the Earth. It uses something called a Doppler shift. So if we well, I don't have this. Go to the next slide. The video. I'll explain it. So basically, we can't really see a planet around a star, so we look at other things. So you can see the star there, you have a planet orbiting around it. Well, as the planet orbits around the star, it tugs on the star, and it causes, if you look at the bottom, it shows a spectrum. It goes to be, it's blue shifted, and then it's red shifted. See how it's changing color? So basically, if this particular star was made of hydrogen, we would see the hydrogen line move to the red when the star is moving away from us, and it would shift to the blue as it's moving toward us. And that displacement from where it should be to where it is at the time gives us the radial velocity of that particular object. And that's the same thing they use for police radar. That's how they tell how fast you're going. They shoot a laser beam at you, and they know where the spectrum should be at, and then they look at the displacement. So if your car's going 10 miles and over, and you're coming toward them, it's going to be blue shifted, and it's going to be off from where it should be, and that displacement gives them the speed that you're going in your vehicle. And we use that same thing here. So you can see right here the dark line spectra as the star. We're not looking at the planet, we're looking at the star. As it is pulled by the planet, you can see the dark line spectra shifting from the red to the blue, and that's how we know that there's a planet orbiting that particular star, just by the light that it emits.
Is it possible for new planets to be created?
There's new planets being created all the time. There's called, they develop around protostars. There was a slide.
I have a video he gave us last week. I'll show you.
Yeah, it shows
Yep.
protostars.
I'll show you that. So here's the Doppler shift in kind of detail. And the one thing you know is if you want to beat police radar, you just need a car that absorbs radar. So from the gun. Jeff, what's this? What's
Well,
this
you
slide?
can actually jam this. I've done it before.
Scratch that from the video.
Well, I had a truck driver friend.
Brian, you didn't hear that?
I had a truck driver friend that wanted me to build him a thing that would jam police radar. So you can actually emit frequencies that will change the Doppler shift. And he could set the speed that he wanted his truck to display on radar, and he got caught, and he came back to work one day and told me he got caught because he was driving down his street, and a police officer clocked him at 55 miles an hour. So he forgot to turn his device off, so he got caught. But I don't recommend this. It's against the law. Let me put that,
Yes, it is. We're going to timestamp this and cut that out. So, but Doppler shift is how they find a lot of things in space. This next slide is kind of, Jeff, can you explain this next one here?
Yeah, this is another way that we look at exoplanets, and this is done with a photometer. Again, the device I told you that measures the light intensity coming from a star. So what we're looking at is we're looking at the starlight, and then what happens is you can see over the upper left, you can see the brightness level, and as the exoplanet passes in front of the star, the light curve dips until it gets to the other side of the star, then it comes up again. So when we see these dips in the photometric curve, we can tell that there's planets orbiting that star as well. And if you look at the intensity that it drops, you can actually calculate the size of the planet that's orbiting around that star. Just like if you look at the Doppler shift, how much that's pulling on the star, we can figure out the mass of the planet as well and get a pretty good accurate size of how big this planet is.
What's the question over here? Can you check the age of a star with Doppler shift?
No, we usually check the age of the star by its color. New stars, there's something called an HR diagram that tells you how old a star is. Blue stars are relatively young stars. Red stars are older stars. Our star, and they classify these in spectral classes. So our sun's what they call a G2 star. It's in about the middle of its life. It's a yellow star. But that's how, and we use photometers. We take data using photometric filters to figure out the exact color, like B minus V, or we use ultraviolet, red, infrared, visual filters to figure out the colors of stars.
All right, we got another question. We'll go John first, then Carrick.
Back to time and speed. So you have a star that you're looking at. It's actually burned out a long time ago, but that light's still coming. Is that
Right, it's still coming to us right now. So the stars we're looking at, like that, if we looked at an exoplanet here, that star could be gone by now. But you're seeing stuff. Again, when you look into space, you're looking back in time. The closest star to our Earth, next to our sun, which is 93 million miles away. So if our sun was to go out, we wouldn't know it for 8 minutes later, because that's how long it takes light to travel from the sun to the Earth is 8 minutes. So the next closest star is Proxima Centauri, which is 4.2 light years away. So it would take light 4.2
So we're seeing
years.
what happened 4.2 years
ago
when we look at it. And in this diagram, just to be sure, that black spot is not actually there when they look at these stars. They're just looking at the light, and that's how they're figuring out there's something moving in front of it.
Yeah, like I said,
Did you have a
light's very
question?
important.
What's your question? Can stars be made too? Yes. Yeah. I'll just show you some more on that. We did that last week. I got a video for you. Don't worry. So let's go to life in space. Our big topic for tonight. We want to do some of those fun things. Oh, did you want to show the wave first? Did you want to show the wave?
I don't need to show it.
Okay, we won't show the wave. So life in space. This is the I Heart Bunko picture that I didn't get to show this morning at church because we don't know why. Something happened on the computer. But this is the picture, a bigger picture of the Drake equation. And Jeff, would you explain more about kind of what the Drake equation is? Maybe go a little further than we went this morning on that.
Well, basically, this is an equation that calculates how many planets in our galaxy can harbor life. So what you basically, the first one is the number of technically advanced civilizations that are out there at the present time, the rate of formation of stars in the galaxy, a fraction of those stars have planetary systems, and we do that by that method I was showing you with spectrometry or photometry. They're kind of getting a better number. And these numbers are changing all the time.
How many planets do we know of now? You were telling me the other day. Roughly, you don't have to give an exact.
There's over 1,000 that they found already.
A year or two ago, there were a couple hundred?
Yes, and we're going to give a sheet. I've got some examples here. There's right now, let me see. "17 planets that they found that are basically Earth-like planets. They're in what they call the Goldilocks zone, which is the zone that's not too hot or not too cold that'll support life. It's just right.
And people like Jeff, who are citizen scientists, are the ones helping them discover these planets, right? This is not just, just NASA scientists. There's people all over the globe who do what Jeff does, that observe these things and help figure these out.
90% of the discoveries are made by amateur astronomers.
So one day, we're going to discover the Thrush planet, and we can all move to planet Thrush. Some more of these, the number of planets per solar system, the fraction of suitable planets, which, of course, as Jeff said, there's 17 that we know of, the fraction of life-bearing planets on which intelligent life emerges. I think that number is 1, because that's us. And then the fraction of civilizations that develop a technology that releases detectable signs. And then the length of time such civilizations release detectable signals. And that all comes down to equal n, which is how many they believe, which that fraction I showed you today, it's always changing, but they believe there's 23.1 civilizations in the Milky Way. That's one astronomer. Could be different viewpoints. And then if you go to the people that believe in special creation, the answer is always 1 for them. So they would not operate with the Drake equation because they don't believe in life outside of it. So it just depends on where you believe life on Earth versus life in space and where you're going to be. But these scientists will be looking for life outside, and so that's what the Drake equation would be. Anything else you want to add with the Drake equation?
Nope, that pretty much covered it.
Good question?
So this is more something I was researching about Kepler 186f, which is one of the planets that normally considered its house life. Do you know anything about Kepler? Do you know anything about that?
I don't know anything directly. I'd have to go back and look. What did you say it was, Kepler?
186f.
186f, yes.
John came with science.
It revolves around a star with a spectral class of M1V. Its radius is 1.17 times the mass of the Earth, so it's very close to the Earth in size. And it orbits its star in 129.954 years, days.
It was close to, I was researching about it, it's close to how Earth was.
Yeah, again, we don't have any direct, we can't take spectroscopy of the planet because we can't look at the reflected light coming back from the planet because it's so close to the star. We can only look at the effects that this planet has on the star that it orbits. So we don't really know what's in the atmosphere, what the atmosphere is made out of. It's just in the Goldilocks zone.
And it's 591 light years away from us, so it's a long way.
For 129 days, wouldn't that be so close to a sun that it couldn't have light because it would be so hot?
No, because there's stars that aren't that, hot as our sun. If it's a white dwarf, it's at the end of its life. So stars, it depends on the mass of the star, how much nuclear fusion is taking place in the core, how much energy its output has, and things like that. So they take all this into consideration. Then they can calculate where that Goldilocks zone is. There's also something we haven't talked about either. I don't want to get too technical, but there's something called a Roche limit around a planet or a star as well. And if a body gets in that Roche limit area, it gets pulled apart by gravitational tidal forces of the star or planet. So that's probably what happened to some of like a moon around Saturn. That's why we see the rings around Saturn today. It got into that Roche limit around the planet Saturn. It was tore apart by Saturn's tidal forces.
I just have one.
Sure.
Did you say that the sun was in its midlife?
Yes.
Yep.
That's biblical, I think, because God created it. I've always said this for years when the people say it was born, how many years old, the sun would run out of energy.
Well, again, the reason why that's the way it is today, and people, again, I think I mentioned this before, but our sun is a third generation star. There was 2 other stars before our sun that was in the heavens before our sun was formed. So, acted as a star, not a sun for us. But, again, we're talking about the universe is large, and I think, Kyle and I both agree on a young Earth, less than 10,000 years old. But I believe that the universe is, billions of years old, because there's several passages in the Bible that explain that. So, I'm not sure where Kyle is with life on other planets, but for me, I don't believe we're going to find life on another planet. I really don't. If we do, it's going to be, a false positive, because, again, when the planets were formed even, there was something called the heavy bombardment period where they were getting hit by meteors and asteroids and stuff, and parts of them were flying off the planet. Now, there's several people that have found, pieces of Mars here on Earth, and I'm sure there's pieces of Earth on Mars and, some of the other planets when they were being formed. So, again, I take the biblical view that, this is a special creation of God, and I really feel that, if there were other aliens, we would have some kind of reference in the Bible to that other, external life.
Good. So if we did find life, good transition here, what would it look like? And I'll just say for mine, I don't think, they are searching hard to find life, and there's been no evidence of life anywhere. They're really looking hard. But I believe if we did find life, it's going to resemble our life, very much the same as what Jeff said. Life has to go from somewhere else. It just doesn't spontaneously appear. We don't believe that in any way, shape, or form. So it would have had to have gotten off our planet to somewhere else. And if you think about it, human DNA is likely more similar to plants than different. For example, we share approximately 60% of our DNA with a banana plant. So in some ways, you guys are bananas. And so ultimately, God used the same framework. We talk about this, the physics of the universe are the physics of the universe. It's not like the Milky Way and our galaxy is different than our neighboring galaxies, and physics work different. God's blueprint is God's blueprint. So God's blueprint for life is God's blueprint for life. So even though we don't look like a banana plant, our DNA, God structured DNA to work the same, the helixes and all that. So God had a plan for creation of life, for creation of the cosmos. So what I believe is they're going to find, when they find something, it's going to be DNA that God uses. It's the blueprint, which is going to prove God. So, and it's going to be hard for scientists, and they're looking for this whole thing. We talked about cosmic loneliness today. I really believe that people are looking for some kind of purpose in the stars. If they would just understand that God created them, they would have the purpose that they're looking for. So they're trying to find it elsewhere. We talk a lot about that. And that leads us kind of in the next part. As we look to the science of this, I think it's fascinating. I just don't think they're really probably going to find anything. And so they get their hearts broken all the time because it's now that I've been searching this and researching this, every article in my newsfeed is science and space. Like Brian and I saw the same article this morning. I saw it right before church. I saw they had the radio waves. I don't know if you've seen this one yet. The radio waves, they colored them digitally of the interior of our Milky Way, and it's beautiful. Like we can't see it, those frequencies, but it's just beautiful what it looks like in the center of our galaxy. So they're doing all this cool science, but they're not able to find what they're looking for, which is really hope. They want to find hope. And so some of the planets give us an interesting discussion about this topic, which the first is Saturn. And you can learn a little bit about Saturn. Now, we know Saturn is famous for its rings. And this is a cool picture that Jeff had showed me, which would be fun to show you. So this is Saturn. Jeff, could you share a little bit more about what we're seeing here?
Sure. This was taken by a spacecraft called Cassini, and it was taken when the planet was backlit by the sun. And if you look to the upper left, that little dot you see is the planet Earth. It's right next to the E ring around the planet Saturn. So it gives you a little perspective of how small it is. And this is just inside our solar system. Our solar system sits inside of our Milky Way. Our Milky Way sits inside of other galaxies, and then all those galaxies are all over the universe. So
we get a little dot on that little dot that says you are here. So that's us. And then Saturn's moons, one of the interesting and fantastic things that have been coming out recently is the moons that are in our solar system, because ultimately we can't see any of the planets. Like Kepler 186f, we can't see it. We can't see if there's water. We can't see any of that. They can just see it tugging on stars, and they can see it like dimming the light of stars. That's it. Like when they say they discovered a planet, there's always a picture. Don't believe the pictures, because it always says in the bottom, artist rendering, always. And so if you want to, you have to go back to NASA's website and then look for actual pictures, and there's very rarely any, because it's like pictures like we're showing you, like wavelengths and all that kind of stuff. It's not actual rendering.
there's a good point. I mean, if you go back and you get some of the older astronomy books of the day, Venus is a perfect example of what Kyle's talking about. When astronomers first saw Venus in a telescope, it was a planet covered by clouds. So they imagined this planet that was very tropical with wetlands and a lot of teeming with life and green plants all over the place. Well, the Russians sent a probe, Venera 1 spacecraft to Venus, and the spacecraft lasted about 15 minutes after it landed. The temperature on Venus is over 900 degrees Fahrenheit. It's got sulfuric acid clouds. It's the closest thing to hell you're going to find in our yeah, so is the inside of an oven. But yeah, so I mean, there's all kinds of renditions. Even Mars, they saw these canals on Mars, and they thought there was intelligent life there, but it turned out to be, just a pipe dream like they imagined Venus to be.
Unlike ancient aliens, like you were talking this morning, and they can't figure out how they cut perfect circles and stones, or triangles or whatever. I think they're still trying to figure that out, and they're saying that that aliens must come down with a laser or whatever. I guess so you don't believe it?
No, I don't believe any of that. I mean, man
The Bible
is
actually
very
has good explanations for all those things. So,
yes.
and I can give you a few. Like in the genealogies in Scripture, which people don't like to read necessarily because genealogies are boring. Just someone's so and so and so and so, or sons of so and so. But in there are while life was after post the garden, and there were sons of Adam and Eve. Some of those descendants are recorded to been given by God the ability to do engineering and take care of stuff. So we all picture dumb people back in antiquity. They weren't very smart because we have technology, we have cell phones. They were super smart. And that's the problem. We all think one thing, but the issue is God gave them the ability to create technology, life. Now, not advanced technology like we're used to, but the technological things that were necessary. And then they abused what God had given them, and God wiped them from the earth and started over. But in the midst of all that, God had confused their languages. God had made it difficult for them to connect, and that's why they spread. So, like, God took care of that. So we don't get to see, and we can't look back and see how smart they were, but they were not the ignorant people that we think they were. They were very technologically advanced. That's why when we look at the pyramids, we're still astounded by how they do it. When you look at the Mayans and what they were able to move, and Easter Island, all these things, they were not stupid people. They were very smart, and they were very ingenuitous, or whatever it is. So they're industrious people. But we just have to get rid of that thought pattern that people who are not modern are not intelligent. They were very intelligent. But they had penalties for their disobedience, which I think cost them their intelligence. And that led them to the Dark Ages. If you look back through history, people were very smart up until the Dark Ages. And then wars and battles and plague took away a lot of that was recorded at that point. Anything you want? So we'll show you Saturn's moons. This is the Cassini spacecraft. This is what they sent up in space. That's why we're getting all these beautiful pictures. One that we showed you today was the planet Enceladus, which will be next. But Jeff, you want to say anything about the spacecraft?
Go back to that one slide. I wanted to point something out. This spacecraft is different than a lot of spacecrafts that are launched. This one's going out into deep space, so you'll notice there's no solar panels anywhere on this. They can't harness the light from the sun. So these use nuclear reactors. But what I wanted to look at, if you look on the right-hand side of this spacecraft, see that little dome shape? That's the Huygens lander. That's what they detached from this Cassini division. That's what actually landed on the moon Titan. It took some beautiful shots of Titan, and we'll talk about that in a minute.
So next is Enceladus. This is a picture. I love this picture because I think it looks like it's straight out of Star Wars, but this is a real moon. And so this is Enceladus. And Jeff, tell us a little bit about the blue. What is the blue that we see here? The blue tiger stripes,
they call those the tiger stripes, and this is where these water plumes are being ejected from the planet's interior. If we go back to the other slide, I want to show them one thing. If you look at a planet, you can tell a lot about the geology of the planet just by looking at this image. You can notice on the right-hand side, see all the craters? On the left-hand side, you don't see that. That's because you have these plumes of water shooting up, falling back down on the planet and freezing. So it's covering up all these, meteor impacts. So this is one of the reasons that they found out that there was water, being driven up through these fissures, what they call the tiger stripes. And they actually, when the Cassini division was orbiting Saturn, before they dove it into Saturn, we'll talk about that in a second, they actually flew it through these water plumes, and they determined that they had salt water, and some other chemistry in there that could possibly support life.
Next one, yeah. And so this is how it works. There's just hydrothermal vents that shoot up, that warm up the water, which then causes it to shoot up through the ice and go up into the atmosphere. And the picture I showed this morning was kind of a picture of what Cassini would have flown through, those steam spouts. Give us the next picture here.
And those spouts, those water spouts he was showing you, that's caused by the gravitational pull of Saturn. Jupiter, we'll show some shots of Jupiter too. That's called gravitational tiding. It's like pulling and stretching the planet, which heats up the interior, which causes it to heat up the water that shoots up through these plumes. So even though the sun is so far away to actually warm the planet's disk, there's actually gravitational tidal forces that are taking place in the core of these moons that are causing liquid water to actually, be in a liquid state and possibly support life.
And why they think they're going to find life outside of our planet is because of things like this. There's water and salt water, so they think, well, if there's water, there must be life. And although it's not necessarily a very hospitable environment, this is what gives secular scientists the hope that they're looking for, that they fly through this. Now, with what Jeff had told me with Cassini, the problem is they're very worried about earth contamination of these places, because if a bacteria goes from here to there, we could be sending life inadvertently. And so how do they take care of that?
Well, they did the same thing with Jupiter, but they ended up putting the spacecraft Cassini, when they were done with the mission, into a death spiral into Saturn, because they don't want it to sit out there in orbit and then crash on one of these moons and then contaminate it with bacteria and stuff from the Earth. So that's why they dove it into Saturn's atmosphere. And Saturn's a great planet because it's although Jupiter has a lot of moons that could support life, Jupiter is the largest planet in the solar system. You can take every planet in our solar system and stick it inside of Jupiter and still have room left. Jupiter's 88,000 miles in diameter. The problem with it is it's a highly radioactive source in space. You can't even get anywhere near that planet without dying of radiation poisoning.
So then this is artist concept on it, which is what it said.
This is not, oh, that is an artist concept. I guess I thought that was a regular shot.
The planet is not. The
No,
plumes,
the
they've
plumes
tried
are.
to give an artist concept of what it would look like.
So they've enhanced it.
Yeah, they've enhanced it just so you can see it.
Well, they've actually got actual shots from Cassini of these plumes as well. They're just not in color. They're not pretty
they're not
like
as
this.
pretty, yeah, they're not as pretty. It's very sciencey. So, all right, let's go to the next. After the next one here is, what is this planet?
This is another moon of Saturn called Dione. And again, you can see the white streaks going through the moon, its surface itself. What they think this is water being pushed up to the surface and then freezing. So that's why it's white as opposed to the gray surrounding area. So again, this is going through some gravitational tidal forces from the pull of Saturn, which is causing the water in its interior to liquefy and come up to the surface and freeze.
So when you hear like they discover water somewhere, they always say then that we're going to find life. Like water is just part of the building blocks of the universe. It is not like this special thing that we only have on Earth. It's everywhere. It's on. I think Pluto's got water. I think they say it's frozen. So there's different temperatures and how frozen it is and what it's mixed with. But like doesn't necessarily mean like God didn't create life on Earth, because like He did. Water's just part of what you'll find on planets and you'll find in the solar system. This next one is a picture of
Titan. It's the largest moon of Saturn. This moon is actually bigger than the planet Mercury, to give you an example of how large it is. The orange color is caused by methane in the atmosphere, and you can actually see that it does have an atmosphere. You can see the blue tinge around it as well. So this moon is interesting because this is the first moon where they found liquid in lakes. And the difference, the difference between this one, if you look there, that Huygens spacecraft landed near the equator of this moon, and they didn't find anything. They were expecting to see some kind of liquid on there, but they didn't find any. So they ended up finding it up by the poles. And these are, instead of water, this moon's so cold that this is actually liquid methane. And this planet actually rains liquid methane, where our planet rains liquid water. So it's amazing. It's the first planet we've ever seen any kind of, or the first moon, I should say, where we've seen any kind of rainfall at all. So just to give you an example of liquid methane, water freezes at 32 degrees. So water can be a gas, liquid, and solid, on Earth, depending on the temperature. Well, on the planet, the moon Titan, methane can be a gas, liquid, and a solid. So it kind of parallels the Earth a little bit, but instead of liquid water, it's liquid methane.
which is not a place you want to live because it is negative 296 degrees, which methane freezes at, which means it's between 296 and 258 degrees negative Fahrenheit. So it's very cold. So just because there's lakes of methane doesn't necessarily mean there's life. But there are, in our conversations, there are scientists, there are places in our planet where there's a high methane content where they're finding different life, like on our planet. Still, same as us, DNA biologically. But so they're believing on planets like this, they may find some, is what their hope is. And so we don't necessarily agree that they're going to find that, but that's kind of where they're at. And then next is, what's this?
This was a shot taken of Huygens, and it shows the lower left shows its flight path as it went down to the planet surface. But this is an image taken of the mountain ranges and things on Titan as it went through the atmosphere. Now, one of the things that scientists believed, planetary geologists believed, that they couldn't understand why the methane atmosphere wasn't being whisked away or evaporating into space. Something had to keep feeding this. And that's where these lakes came into consideration, because like the waters of the earth that get fed by underground springs, these methane lakes on Titan are being fed by underground lakes of methane. So you have that same water table, it's only methane table on.
And this is just a neat bonus picture. This is actually a picture of Titan from, I think, Huygens that landed, and this is a color photo that we have of Titan's surface.
And again, they didn't find any liquid anywhere around, but what they found is, if you notice the rocks, they're not jagged, which indicates there was some kind of liquid flowing on the surface to erode these rocks like they have been eroded.
And then next is Rob Hutzman's favorite planet, Uranus. So and we have these are some moons around, a moon around Uranus. So
Yeah, this is Triton. This is the largest moon of Uranus, and actually this moon's going to be destroyed about 1 million years from now. It's actually spiraling in toward the planet, and it's going to get into that Roche limit and be torn apart. But again, they see signs of liquid water on this planet, so they believe that this particular moon may have water and could harbor life.
and if you're following anything in science in our solar system, they're finding water everywhere, liquid. They're finding it everywhere. That's just a normal thing. So, and it's always, I see and read these articles, it's always followed with, we're going to discover life. Yet they have not found life or any evidence of it. So they keep looking, but they're not finding it. Jupiter's moons, here are some other ones. What's this next moon here?
Yeah, this is the planet, the moon Io. This is the moon that orbits closest to Jupiter, and this was the first first moon where they found volcanic activity on. If you look up at the upper, top of the planet there, that plume is actually volcanic material being spewed into space. And if you can look at the planet, again, one thing that you notice is it's devoid of craters. So this planet, or this moon's surface, is constantly being re-engineered by lava flows and things like that are covering up any signs of any crater impacts that have taken place. But again, this planet is being pulled and stretched immensely by the planet Jupiter. Almost like the same kind of thing. You have particles that are rubbing together. If you rub your hands together, you start generating heat. Same thing's happening in the core of a lot of these planets.
And they just found, recently, the moon is having lots of earthquakes because of the way that the Earth pulls on it. And it actually has, continents and plates and all that, so they have earthquakes. They've been finding that on our moon. This next one is this.
This is Europa. Again, there's 4 large moons that Galileo found in his telescope. He discovered in his telescope, and these are the moons that we're going to show you now. Europa is another moon where they believe there's liquid water. If you look at the surface, you can see where meteorites have hit the surface, and where it hit the surface, it punctured through the crust of the planet, and water seeped up and froze inside these craters. That's why you see these white spots, which they think are frozen water.
And next is...
And this is Ganymede. This is another large moon of Jupiter, and you can see the same type of fissure cracks and things in the planet's surface, which indicates that there's something liquid underneath it. We see these kind of, effects in the North and South Pole with the ice packs.
And then finally, this is a test for Jeff. It's impressive he's gotten all these right. Or at least we won't know if he got them wrong. Do you know this one? What's the slide say back there, Linda?
Callisto, sorry. Yeah, again, same thing that we just showed before. You can see the crater impacts where water has come up through the surface and frozen on the planet's surface or inside the crater itself. So again, these are some of the moons that, planetary scientists have a lot of faith that we may or may not find life, but they're hoping we do. And again, there's a lot of research that goes into sending a probe here. They've got a probe that they're working on for Enceladus, but the problem is that, again, once we launch this thing out into space, they're going to have to find some way to sterilize this thing before it gets into the moon's surface, because they don't want to contaminate the moon with bacteria and stuff from the Earth. So they're working on a spacecraft that will, do that as it's flying into the moon, and then it'll land, and then there's a probe that's like a capsule that's going to heat up, and it's going to melt its way down through the ice crust of Enceladus, and then when it gets into the liquid water, it'll eject a underwater probe that'll be able to go around and look for life. But again, they're still a ways away because they still don't have all the bugs worked out. It's very difficult to go someplace like that and not contaminate it.
And the important reason to learn these things, I think, from a biblical perspective is, I remember sitting at the University of Michigan in class being told that because they were just starting to find evidence of water, because science has changed a lot in the 20 years since I was at university, like, that was the belief that, like, we weren't special. But the truth is, they're finding water everywhere. Well, they're finding water on Mars. That was like 3 years ago. They found water on Mars. They looked at the same spot over and over again. They could see, like, there was moisture in these downflows from these, like, mountains. And so that's like big news for them, but it's not big news for us because that's normal. There's all different types of liquid depending on the different temperatures, how cold or how hot it is. Different things have freezing and melting points. And so ultimately, for us as Christians, that doesn't mean anything other than us than great. It's just more proof that God has a big plan, and it's beyond our planet with how he created our universe. So don't let some of the news stories, like, that was hard for me back then, was trying to say, okay, what does this mean for my relationship with the Lord? And the truth is, it doesn't really mean anything, because science is the same across the universe. And so we have to know that they're going to find things that are similar, like with the building blocks of planets and stars in other places, because that's how God created everything. So that's been one of the best perspectives for me. The more I've learned, the more it's solidified my view of a young earth, and ultimately of God's creation plan and where we fit in that plan. And like I said, I don't know, like I said this morning, I don't know if they're ever going to find life somewhere else. It doesn't matter to me if they do. I'm indifferent to it because I don't know that they're ever going to find it. I don't think it's likely. And my son even affirmed today after service on the ride home, he said, Dad, really, if they find life, I hope they never find life, if there's life out there, if God put it somewhere else, because of what we as humans have done to all civilizations that are less advanced. And so, like, because he's like, I'm watching history, I saw what the Europeans did when they came to Americas. And so that's his view. But, like, we have to take that into account. Like, this is great for conversation because there are people you probably work with, people in your neighborhood that have belief in life. The statistics say that well over 70% of all Americans believe there's life off planet. So that is the number. So it's not like it's a rare thing. Like, most people believe they're going to find life outside of this planet. And if you see the constant barrage of science articles, they're announcing that they're doing it ahead of time. But they've been announcing it my entire life that I can remember. We're about to find life, we're about to find life. And so in like 40 years, they've never found life. Now, I've only lived 40, but I think we've talked, they've been saying that since they went to the moon. And they've still yet, they thought they were going to go to the moon and find evidence of life, and they've yet to do it. So, that was what, 1969? They went to the moon? Yeah, see, that's a good test for me there. But one of the other things I think is neat is we talk about all of this life, and we're not here to tell you they're going to find life or not going to find life, because ultimately we don't know. We just have what our beliefs are. But we wanted to help you have intelligent conversations with people who do believe they're going to find it. Like, there's all these shows on TV because there's such a belief in our society that there's aliens, the aliens are visiting us, we're going to find aliens on one of these planets or moons. And we just want to equip you with, like, a biblical perspective. It's okay if you think they're going to find life on another planet. That's totally fine. There's nothing wrong biblically with that. It's okay if you believe they're never going to find life on another planet too. Biblically, that's fine. It can be supported. We can have the liberty to have those healthy conversations. I'm with Jeff. I don't think they're going to find something, but it's not going to change my faith if they do. And so that's really where I think you have to have some of those discussions. And we've been trying to find life, and this is astounding. I think it solidifies probably your reasoning that you share, like you don't really think they're going to find anything, is about radio transmissions. And Jeff shared this with me tonight, and I was like, oh, wow, I never thought about that. But Jeff, can you explain some of this to us?
Sure. back in, let's see, December 23rd, 1900, man made his first radio transmission. And I think a year after that, they started broadcasting on December 24th, or not a year after, but 1906, so 6 years later. So from 1906 to now, that's been 113 years. So that means 113 years of radio signals have been going out into space from the Earth at the speed of light. I did a small calculation real quick, and looking at the area of our galaxy and how far those radio signals can travel. At the present date, it would have went out to about 320,000 stars. Now, man has only been on this earth for a short period of time, but the universe is billions of years old. Now, if there's other intelligent life out there that has developed radio technology, and I'm sure that a lot of this stuff is going to parallel, with our planet, you would think that we'd be seeing and hearing these radio transmissions from other planets. There's a organization called SETI, Search for Extraterrestrial Intelligence. They've been doing, searching for extraterrestrial intelligence for many, many years, and they found things that they thought were, extraterrestrial life, like Crab 1, this star that's supernovaed in 1054 AD, has a pulsar, and it's spinning at 30 times a second. So it's getting this consistent pulse that they're picking up on radio telescopes, and they thought that was intelligent life at first, so they actually did some research and found out that it's just a star that's spinning very, frantically on its axis and putting this optical beam of energy past the Earth every, 30 times a second. So, that, and SETI back in 1974, they sent a signal to M13, which is a globular cluster that's 23,000 light years away from us. They sent a 2 or 3 minute message that contained 1,679 bytes of information that talked about the Earth and mankind and all that stuff. And like I said, with all these radio transmissions that have gone out into space for years, and the universe being as old as it is, we haven't heard any signals from anybody, received anything, or got anything back from what we sent, which I just, think to myself, it's counterintuitive to the biblical view of the Bible for God to put life on other planets. He came to Earth, Jesus came to Earth and, gave up his life to, for us. And it doesn't talk about doing that with other alien life. Now, I can sit here today and tell you that we will find life outside of the Earth. I'm 100% sure of that. And that's going to be when we all go to heaven.
Go ahead, John.
Back in the 50s, I remember my dad was always interested in this stuff. And there was what he called the big listening ear that was like north of Ann Arbor. And I know driving by it, watched it, was to receive radio signals. And we're talking the 50s and the 50s.
Yeah, that was a radio telescope they used. That's what they used to find out the background radiation. They thought that radiation, they were getting this noise constantly in the receiver, and they thought it was pigeon droppings that were on the antenna, so they went out there and scrubbed this whole thing down, and it's a nice story if you want to read it, but they ended up, cleaning the whole thing up, and they still found this background radiation that's still there. And you guys can hear it when you turn your TV set, well, the older TV sets, I guess I'm going to show my age, but years ago when you used to go to like channel, 23, all that static you hear in the background is remnants of the, the creation of our universe is what they think. But yeah, I for one, like I said, I keep an open mind, but I just, studying the Bible like I have, I just don't see, us finding life. I think that, like I said, I think Kyle said it today, and I got it in my documentation here. God created the earth for man, but he created the heavens for himself.
But you also won't be surprised if there's microbial life.
No, not
there's
microbial
lots of
life,
different
no,
explanations of how that could happen. So
Yes.
we're talking life as in us, like beings
Exactly.
is what we're saying when he doesn't think life. Because there's lots of reasons microbes could be elsewhere, and they're very scientifically explained with meteorite hits and all kinds of stuff. And the thing is, if there is a civilization M13, our message won't get there for 22,955 light years, and then ultimately, or years, and then we won't get a message back for 23,000 years. So we're about 46,000 years away from finding out if anybody's actually there. So it's nothing to be worried about if there are. But ultimately, when we look at 320,000 stars in range, you know, our star has 9, or is it 8 planets now?
8 planets.
8
Yeah.
planets. I still
Pluto's a
count Pluto.
dwarf
I don't
planet
care.
now.
So 8 planets, but if every one of those stars had 8-ish planets at it, we're talking about 2.4 million planets and no intelligent life from 2.4 million planets. And yeah, they're not all inhabitable, but like that's where we go to the understanding like we very well are a special creation. We know it in the Word of God. And so I hope that's encouraging to you. It's encouraging to me. As much as we've been searching the stars for centuries, they've also been listening to the stars since World War II. The Nazis and the Americans had all these telescopes, and they were searching for the stars. They were looking for any advantage over each other. So we have been listening to outer space for decades, and still it's silence. There's nothing. And every time they do find something, it's always explainable in nature. And so it's just the evidence continues to overwhelm that we are alone for the most part.
Well, this is off base a little bit. Why are they teaching our youth today in school and whatnot that they're 2 years old and all that? I don't understand the reasoning. I don't understand how they come up with that at all. It kind of bothers me.
Why are they teaching students that were millions of years old? I mean, that goes back to our last couple weeks. Textbooks, like, oh God, just say this. Like, I had a friend in Indiana who just went to some big Red for Ed. They did a big protest, and they went downtown. And one of the things he showed a picture of was one of his books. He's a government teacher. George W. Bush is still the president in their textbooks. So that just shows you where we're at. Like, we're not teaching current science and current history in a lot of our school districts. George Bush has not been a president for quite a few years. And so when you look at how textbooks are purchased and how funding needs to be there to update, like science is changing by the day. They just put out this map of Titan. This is recent science. Like, that is not like 5 years old. That's like weeks that they've announced that. I don't know how long ago was it NASA reported that, but like they just put out the image of these, blue spots. And those blue spots, what was cool is Jeff is like, they're doing these radar tests. And so they're radaring the planet as they go to get a map of it. When the radar gets absorbed, it's liquid. So the liquid absorbs it. The blue is not actually the color of it. It's where the spots they know the radar has been absorbed. So they know there's liquid there, which they know is liquid methane. But which is neat, but that's not in any textbook. So our kids aren't learning any of this stuff. And so if we're not getting involved and invested in learning this, our kids are going to go through school with not current scientific information. I wasn't even learning the correct current stuff in university. Like, we were behind because science is just changing so fast. Technology is just moving so rapidly. You can never write a textbook fast enough because being involved in the author world, someone who's writing a book has to generally write it, and then they have to sell it. And so even in that sense, that can take a year or two. And then once they sell it on a proposal. So they would say, I'm going to write a book about this. The publisher will give them 6 months to 9 months to write it. So that may have took them a year or two to sell it, 6 to 9 months to write it, and then it's a year minimum to publish it. So now when a book comes out with scientific information, it can be 4 years out of date the moment it gets put into schools, and then they want to maximize the opportunity for that book to have sales. So as long as that book is still selling, they will not take it off the shelf. So that's why the books like the George W. Bush's President book, it's all about profitability. Like, these are companies that aren't really caring about what information is out there. They're not changing out textbooks. They're trying to sell a product as publishers to a school. So there's this balance of what these products do. And so we have to understand that. That's why I want to be on the forefront of teaching my kids what's current and true, so they have the best basis. And we have to do that as a church. We have to do that as a body of believers. Our youth group has to be on the forefront of teaching our teens, because our teens, they don't want to hear all the stuff that school's teaching, because they know they can go Google and find out what they're learning in class does not line up with current modern science. So what do you do at that point? And that's where I think there's an opportunity for us as believers who, we've got a lot of teachers in the room, as teachers who can be learning this, teaching our classrooms. It's hard though in public schools to teach what the Bible says because they get fired. But you could have an influence positively on people in your school and classrooms, and ultimately as believers, we can do that, especially here at church. And so that's why I think Nerd Church is great, and because we have a job to do. And I mean, we're talking to kids who haven't even accepted Christ yet in our youth group about these things. And they're telling us that they believe God created the cosmos now. And they never really believe what they learn in school. And they tell us the whys. And it's like they're so close to having a relationship with God, but they're engaging in these conversations with us. And that's why this has been a really great series, because it's been wonderful to talk to our teens and even my own children. But Cody's having a great time having deep conversations about things you wouldn't necessarily think kids want to talk about. It's like, well, I want to talk about more stuff at school, but they really are grappling with this stuff to try to figure out what they believe about the world, about creation, about life, and it gives us a good platform from which to talk. And so that's why I think Jeff is such a great resource for us, and to learn from. And I know he loves talking about this stuff. We were just talking personally about he's like, what do you think? What were you asking me about? Was it if they find life? Was it? Yeah, what do you think about if they find life? What does that mean? And so, yeah, it's a great conversation to have. That's why I got to the banana slide for you. I think it's possible they'll find life somewhere else, but I think God's DNA blueprint is God's DNA blueprint. So I do think it'll look like us. There are theories that Eden wasn't even on this planet. Now, that's kind of like a mind-blowing thing, but there's nothing to say that God couldn't have took Adam and Eve and took them off of a planet, put them on ours. We don't know what happened. I'm not saying that. Don't make me a cult leader because I said that. But there are all kinds of theories that people have about it. There are theories that hell is an actual physical place. People have said that Venus is hell. Now I don't necessarily believe that, but there are people that believe those things, that God's cosmos is huge, and that there are realms the Bible talks about. The heavens as in the first, the second, the third. There's these levels, and so we don't actually know what that means to a grand scale. We don't know if there is a place in the universe that God exists more like the Holy of Holies here in the tabernacle was on earth. We don't know those things. We're going to find those things out one day when we don't care anymore, when we get there to heaven. But God has a bigger plan that we can never even wrap our minds around. And when we engage in conversations about it, it's okay to say, I don't really know, but here's what I do know. Here's the hows that I know. And I think this is fascinating. I love eating chocolate bars, but now I know I can melt them with wavelengths. It's even cooler. So, anything else question-wise people have?
How do you feel about our Earth, with them saying the icebergs and everything melting and stuff like that?
That's a good question. I know Jeff has an opinion.
That we're going to be around?
Well, I think we're going to be around for a long time, until God comes back. That's when we're going to be here till. But, there's a lot of people that they're starting this new green movement. And Con and I have talked about this quite a bit. I'm 62 years old, and going back into the 30s, I can count, I don't have enough fingers and toes to count how many times these people have come up with these, crazy ideas that the earth is going to end because of something we're doing. Right now they're talking about the CO2 buildup in the atmosphere. They're telling you that we're pumping all this stuff in the north and south poles are melting. I mean, I think this is just part of a track that Earth goes through. But what they're not telling you is that the Earth has never been greener than it is today. There's more greenery on the Earth because of all this additional CO2. So God just didn't put us here and He's not taking care of us. I mean, when we pump out more CO2, more plant life springs up to counteract that additional CO2 in the atmosphere.
It needs the CO2 to grow and to thrive.
Exactly. So, again, there's been at least 30 that I know of, and none of this stuff has ever come true. Back in the 80s when, we were just talking about Venus and Jupiter being in conjunction in the western sky, there was a time, I think it was 1982 or 83, somewhere in that area, they were predicting that we're going to have massive earthquakes because all the planets are going to be on the same side of the sun. So, and there was Halley's Comet when it came back, not in the 80s like it did here in 1986, but the prior time than that, there were actually people killing themselves over that because scientists were saying that the Earth was going to go through the tail of Halley's Comet, and they said that the tail contained cyanide gas, so people thought they're going to be poisoned when the Earth went through this, so they were killing themselves. So again, I don't believe a lot of this stuff that you hear. I mean, I
But
really
you do
don't.
believe the earth goes through cycles.
Yes.
And so we're
Goes through
just in a
cycles.
cycle. And if you look at like back in the 90s, the ozone layer, the ozone's being depleted, CFCs, chlorofluorocarbons, all that. The ozone now has grown significantly. They don't talk about, when's the last time you heard about the ozone? Anybody?
Just when they were talking
The
about
90s, right? Yeah. Maybe 2000. But like the ozone, even when they were banning all that stuff, was actually starting to grow again. But like they quit talking about it because like they got all their bans, all that stuff. That's all big money and politics and lobbyists. But ultimately, the ozone now is extremely strong. That big hole that was over Australia and Antarctica is now like a very small hole, and it's just a cycle. And so, if you understand that a lot of these things are cycles, like our icebergs get bigger and smaller all through the history that we know of in our world. Like we're just in a cycle. It's cold right now. Like global warming was a big thing, right? For like 10 years. When's the last time you heard global warming, that term used? Now it's climate change. Because now we're not warmer, climate's changing, we're causing climate change. So we just have to understand there's all kinds of reasons, news sources, and they do this stuff. But like when I talk to actual scientists, they're not worried about any of this stuff. This is all news, this is all for politics, this is all for gain for somebody. But like when I talk to Jeff, he's like, I'm not worried about any of that stuff. Like I look at all these scientific things, and none of that is really what I see is happening. And so it's just something to make us afraid. So you can be controlled by somebody, some organization, some politician.
Somebody's getting rich. Like I said, how many remember the old propane tanks you used to have for your grills? And they had this new valve you had to have that was eco-friendly, that you had to go buy all new propane. Some congressman probably got rich off of that. But that's when I see a lot of this stuff is, like Kyle said, it's something to do with politics. Somebody's getting rich off of this somehow, and that's this whole Green Deal thing that they want to push out on people.
I was going to say, technically, I mean, our climate is changing. That is, I mean, to some extent. But we were doing actual models, like our class, like that. And they were saying there's going to be a 2.5 degree change by 2070, and that was it. So that means yes, it technically go up. 2.5 degrees isn't much. That's that whole the world's gonna die in like 12 years.
Yeah, no, it's all for a purpose. Like I remember when I was a kid, the winter was in November, December, January. Now winter is in January, February, March. And I think we were talking about this maybe. And you said, yeah, you've seen the change of the winter go back and forth. And that has to do with our calendar, it has to do with all these different things. It really doesn't have anything to do with climate change, is why winter becomes later or earlier in the season. It's just part of the cycle of our earth. And when we have more intelligence about these things, we don't become paranoid like media and society wants us to be. We can be steady on our faith in Christ, and that's really all that we need is Christ. And so all these other things are just distractions from what our purpose is here is to grow the kingdom of God. And so that's one of the things we just have to keep our focus in mind and we're not listen to the radical things that are happening. Yeah, our earth is changing, and we're here experiencing it, but it's just not the first time. Like every generation has had to experience earth change and as part of what they go through. Someone have a question, John?
Oh, yeah, I was reading here a while ago, these glaciers are melting and it's gonna raise the ocean levels and our Great Lakes and all that. But realistically, I think that it's already displacing so much water, if it melts, it's not gonna create any more water, am I right?
Yeah, I mean, the frozen water takes up more volume, actually takes no more volume than liquid water. So it's not gonna create any more volume. If you can put an ice cube in a glass and let it melt, the water level stays the same. Like it doesn't, the volume is the same. Now, ice will expand, but the volume actually of what exists is the same. So it's not going to.
Another 70 years, Florida's all supposed to be underwater.
Yeah.
That's somebody.
And they say like the glaciers in Iceland are melting, but the Antarctic glaciers are the biggest they've been in 2 decades. So like our ice and polar ice in South Pole is growing substantially. So, so they take one glacier that's melting, but they forget that in the other part of the planet it's growing significantly. So we're just not seeing all the things they say we're going to see. I was in Miami for a bowl game in 2001. And when I was in Miami, all of the streets were full with water because the sea level rise had flooded the city. Well, the issue is, like they said, in 10 or 20 years, that Miami was going to be unlivable. Well, it's been 20 years. Miami is still livable. Like, so what they were kind of making people terrified that they had to spend all this money to protect their property and houses because in 20 years it was going to be a flooded city in Miami because of the sea level rise. That has not happened. I have friends in Miami. They still have flooding when high tides come in certain places, but it has to do with porous limestone underneath the city, not so much as the sea level raise. But that was what was in the media and the news 20 years ago when I was there. Patty and I were just in Venice, and Venice is flooding, and they have a plan to stop it, but because of bureaucracy, they are 10 years behind because they had 80% of the money for these floodgates stolen. So they have floodgates that they could stop all the Venetian flooding, but they haven't finished the project. So, like, some of the stuff that we're seeing is just because of people being people and taking advantage of financial situations, politics, and we could be doing a better job at really managing our environment
We
better.
do so many stupid things in this country. For instance, why would you build a large city like New Orleans below sea level?
Yeah. Some things don't make sense.
Yeah.
Well, we are behind time or over time, so thank you for coming. We appreciate it. If you have ideas for things you want to hear more about on a future Science in the Bible series, let us know. Jeff and I are talking about some things for the spring. We've really enjoyed doing this and studying. And now, especially that every one of my news feeds is science related, I got to start searching something else online so I have other news come up. But it has been exciting. Thank you for coming to these nights, and we appreciate you being involved.
Yes, thank you very much.